In this video, we're going to see how to use quotient rule to differentiate some set of given questions. And of course, quotient rule is one of the rules of differentiation. I've done videos on product rule and chain rule. I encourage you to subscribe to my YouTube channel so that you can view some of those product rule and chain rule that I've done in the past. So let's see some set of questions here. Quotient rule says that if y equal to some kind of f over g, then differentiating y with respect to x, we're going to differentiate f and then we differentiate g. And then it comes this way. That's g multiplied by the differential value of f minus f multiplied by the differential value of g over g squared. Basically, it's over the denominator square. Or you can also come in terms of u over v. It's still the same thing. So let's just set out to solve some given examples. Number one, if we're given y equal to 7x plus 4 over x squared plus 5. So we can just term the numerator f so that we can follow the concept of quotient rule. And then we tag the denominator to be g. So in this case, our f is going to be 7x plus 4. So f prime, that's to differentiate 7x plus 4. It's actually going to give us 7. And then our g is equal to x squared plus 5. So in this case, g prime, that's the differential value of g, is going to give us 2x. And therefore, the y, the x, it's actually equal to gf prime minus fg prime over g squared. Is that simple? So we substitute all that we have into the concept of the formula written there. So the y, the x is going to be g, of course, it's going to be x squared plus 5, okay, multiplied by the differential value of f, we have it there, multiplied by 7, minus 7x plus 4, in the bracket, multiplied by 2x, and everything over x squared plus 5 squared. And then we go ahead. It's at 7 in the bracket x squared plus 5 minus 2x in the bracket 7x plus 4. Everything over x squared plus 5 squared. And then subsequently we use this to open up the bracket. And therefore, this one gives us 7x squared plus, we just distribute this 7 over the content of the bracket. That's 35 and 7, that's 5. Minus 14x squared. And then minus times plus here, that's minus. That's 8x. That's 2x times 4. Everything over x squared plus 5 squared. And therefore, our answer becomes the y, the x now. The y, the x becomes, we have to rearrange this. That becomes 7x squared minus 14x squared. 14x squared. And then minus 8x plus 35. Everything over x squared plus 5 squared. And then finally, the y, the x gives us minus 7x squared minus 8x plus 35, everything over x squared plus 5 raised to the power of 2. So that's to that very question we have there. Let's take a look at another example. Let's take a look at another example here. Here's another one. That's going to be number 2. Question 2 says if y is equal to 4x minus 5 squared, everything over 2x squared. So we can just tag this to be f, and we tag the denominator to be g. And of course, differentiating y with respect to x, we shouldn't forget this. That's gf complement minus fg complement over g squared. That's quite important to bear in mind. And in this case, our f is going to be 4x minus 5 squared. And therefore, the differential value of f is such a way that we need to use chain rule to differentiate this. Okay, I refer you back to one of my videos on chain rule to study how to use chain rule to differentiate a question like this. And therefore, this is going to be 2 here in the bracket 4x minus 5 raised to the power of 2 minus 1, and then multiplied by the differential value of the content of the bracket itself, which is 4. And therefore, our f prime here, 2 times 4 here, that becomes 8 in the bracket 4x minus 5 raised to the power of 1. So there is no need writing the 1 has the power. And therefore, how about g? If our g equal to 2x squared, and of course the differential value of g is going to be 2 times 2 here, 4x 2 minus 1 is 1 there. So we can substitute all that we have there into the concept of the quotient rule. And therefore, the y, the x gives us 2x squared, which is our g, 2x squared, in the bracket f prime, that's 8 bracket 4x minus 5 here in the bigger bracket minus, and then we have f is 4x minus 5 raised to the power of 2, and then multiply by 4x, everything over 2x squared raised to the power of 2 again. And then we can actually analyze and solve that one further. And therefore, this is going to give us this times this, that should be 16x squared. So this is going to give us 16x squared in a bracket 4x minus 5, and then minus this one can be written as 4x in a bracket 4x minus 5 squared. Everything over 2x squared raised to the power of 2. So we can still take that further to get the y the x here. That's going to give us 4x, this case, and that's going to give us 4x can be used to factorize that out. So if we can write it as 4x in the bracket 4x minus 5, and then in the bigger bracket 4x, okay, minus 4x minus in the bracket 4x minus 5, okay, everything over 2 square here is going to be 4x raised to the power of 4. That's x squared. That's 2 times 2 there. That's x raised to the power of 4. And therefore, we can have 4x. Okay, what I actually did there was to use 4x, which is a common factor, okay, to factorize 4x and 4x minus 5 to factorize everything out there. So I'm left with 4x here minus 1 of this. So I use these two to factorize the numerator. And in that case, we have 4x in a bracket, 4x minus 5. And then here, we can actually open the bracket there. And then we have 4x minus 4x minus times minus here. That's plus 5. Okay, in the bracket, 4x raised to the power of 4. And then we can actually get rid of this 4x minus 4x. That's going to be 0. And therefore, what we have left, it's 4x in a bracket, 4x minus 5. And then multiplied by, we're left with 5. Multiplied by 5. Everything over 4x raised to the power of 4. We can actually reduce this. Okay, this can get rid of this. And of course, x here can reduce x here, so we're left with x raised to the power of 3 there. And therefore, the final answer can be presented this way. 5 in the bracket 4x minus 5, everything over x raised to the power of 3. So that's how quotient rule can be used to solve such question. And then let's take another example. Let's look at another example here. Here's another one. That's going to be my number 3. Here is y equal to x squared minus 1 over square root of 2x minus 1. So we have a complex question here, but quotient rule can be used to sort this out. So this can actually be interpreted as x squared minus 1, everything over 2x minus 1 raised to the power of 1 over 2. That square root of 2x minus 1 can be written this way. So in this way, we can tag the numerator to be f and the denominator to be g. Okay, so don't forget the concept of quotient rule, which says the y dx is going to be gf prime minus fg prime over g squared. So that's important that we copy that out. And then in this case, if our f equal to x squared minus 1, then our f prime is going to be what? 2x. That's the differential value of x squared minus 1. And then if our g equal to 2x minus 1 raised to the power of 1 over 2. In this case, that means we can actually use a chain rule to differentiate this. Okay, and this one is going to be 1 over 2 in the bracket 2x minus 1 raised to the power of 1 over 2 minus 1, and then multiply by the differential value of the content of the brackets, and that's going to be 2. So what I'm doing here is actually chain rule. So we can take this one further. That means the g complement can be 1 over 2 in the bracket 2x minus 1 raised to the power of 1 over 2 minus 1 will give us minus 1 over 2 times 2. And in this case, we can have g prime to be 1 over 2 times these two. Okay, times this one is becoming 1 over 2x minus 1 raised to the power of 1 over 2. So that's going to be expressed that way. So we can actually get rid of half and 2 here to give us 1. So finally, we have g complement to be 1 over 2x minus 1 raised to the power of 1 over 2. So now that we have all that we need to substitute and the quotient rule concept, so we can go ahead and substitute that. That means the y dx is going to give us 2x minus 1 raised to the power, that's g raised to the power of 1 over 2 multiplied by 2x minus, then this one is x squared minus 1, okay, and then multiplied by 2x minus 1 raised to the power of minus 1 over 2. Everything comes to 2x minus 1 raised to the power of 1 over 2 squared. Okay, and then we can actually take this further. Okay, if I'm going to be analytical about this, and that's going to give us the y the x, which is going to give us 2x in a bracket 2x in a bracket 2x minus 1 raised to the power of 1 over 2, and then minus this x squared minus 1. Okay, we can actually write this as over 2x minus 1 raised to the power of 1 over 2. And then everything I've written here is the numerator, then divided by, I choose to write this way so that we can perfectly understand the solution better. That's 2x minus 1. 1 over 2 times 2 here is actually 2x minus 1. Maybe we'll write it as over 1. And therefore, if we're to analyze this, everything here can be taken as over 1. And therefore, the LCM of the numerator itself, it can be written as 2x minus 1 raised to the power of 1 over 2. And then this becomes 2x bracket 2x minus 1 raised to the power of 1, in the sense that 1 into this is 2x minus 1 raised to the power 1 over 2 itself, then times this, and then 2x minus 1 raised to the power 1 over 2. What we just need to do is 1 over 2 plus 1 over 2 here, which is 1. So it is 2x minus 1 raised to the power of 1. And then minus this in itself is 1 times this. And of course, we can still put this in the bracket x squared minus 1. And then all of this is still the numerator. And then we can change this one to multiplication. So this becomes 1 over 2x minus 1. And therefore, we press further by opening up the bracket here. So if you open up the bracket here, what we do have, it's going to be 4x squared minus 2x. That's we're distributing 2x over the contents of the bracket here, minus x squared, minus times minus, and of course it's going to be plus 1. Everything over 2x minus 1 raised to the power 1 over 2 times 1 over 2x minus 1. And then we can actually take it further. And then the next step here is going to be the LCM of 2x minus 1 raised to the power of 1 over 2. And this, and of course, that's going to be, we have to multiply the denominator by this one and then multiply the numerators. So we'll multiply this by this, and of course it's going to give us, I want to copy that out, and that gives us 4x squared, let me just collect the like terms of the numerator there, minus x squared minus 2x plus 1, everything over the denominator multiplied by another denominator. So we do have 2x minus 1 raised to the power 1 over 2, then multiplied by 2x minus 1. Of course, this one is actually raised to the power of 1. And then we take it further, the writing 4x minus x squared, and this gives us 3x squared. 3x squared minus 2x plus 1. And then everything comes to 2x minus 1 raised to the power of 1 over 2 plus 1. And of course, that's one of the laws of indices there. So finally, we can present our answer this way: 3x squared minus 2x plus 1. Everything over 2x minus 1 raised to the power of 3 over 2. And of course, or this answer can as well be presented as 3x squared minus 2x plus 1 over square root of 2x minus 1 raised to the power of 3. So this can also be presented this way. Okay, so that's that question. Thank you. Kindly subscribe to my YouTube channels.